everyone. Welcome to the classroom of Advanced Manufacturing Technologies for Welded Structures. I am Yu Ron. Today, we will delve into the operation of robot flame cutting and blanking. First, let's get to know the equipment and material preparation. Inspection of equipment. 1. Inspection of manipulator status. Confirm that each axis moves smoothly without jamming and has sufficient lubricating grease. Check the sensitivity of joint limit switches to ensure no mechanical interference. 2. Inspection of cutting torch installation. Ensure the torch is firmly clamped and the coaxiality of the ignition electrode and nozzle is within less than or equal to 0.2 millimeters. Adjust the cooling water pipe connection to ensure no water leakage. 3. Inspection of gas circuit system. Gas, propane/natural gas pressure 0.05-0.1 megapascal. Oxygen pressure 0.6-1.2 megapascal. Detect gas pipe joint leakage with soapy water and replace any aging pipelines. 4. Testing of safety device. Trigger the emergency stop button to verify that the robot stops immediately. Test the effectiveness of the grating protection area alarm function. 2. Material handling. 1. Workpiece fixing. Fix the workpiece with a magnetic shock or special clamp to ensure the cutting area is suspended. Ensure the distance between the workpiece and the cutting table is greater than or equal to 50 millimeters. 2. Surface treatment. Grind the area to be cut. Preheat thick plates, greater than 30 millimeters, to 80-120 degrees Celsius. Next, let's move on to programming and path planning. 1. Offline programming. 1. Model import. Import the 3D model into the software. 2. Path generation. Set the cutting starting point and add an introduction line. For the nesting, refer to the chapter of Plasma Arc Cutting. Optimize the cutting sequence to avoid manipulator singularity points. 3. Collision detection. Simulate the program operation to check for interference risk between the torch and the workpiece/clamp. Adjust the path or posture angle, plus or minus 15 degrees, to avoid collisions. Robot programming requirements. Bevel groove processing sequence. The programming sequence of the cutting path is generally from small angle to large angle, i.e., cut 22.5 degrees first, then 35 degrees. Cutting height, h. Generally, the distance from the flame core tip to the workpiece is 3 to 5 millimeters, i.e., the distance from the nozzle to the workpiece, h, is preferably 7 to 10 millimeters. Too small a distance will melt the incision edge and increase carbon content, while too large a distance will prolong preheating time and cause bead slag hanging on the upper edge of the cut. 2. Parameter setting. Set parameters according to the process card. Parameter selection. Select corresponding parameters: nozzle type, gas pressure, cutting speed, counterpoint length L, according to different plate thicknesses and angles. The next step is trial cutting and calibration. 1. Dry run test. 1. Track verification. Close the gas valve and run the program to check the smoothness of manipulator track. Verify that the repeat positioning accuracy of key points is less than or equal to plus or minus 0.1 millimeters. 2. Ignition and trial cutting. 1. Flame adjustment. Manually ignite and adjust the mixing valve to achieve a neutral flame. Bright flame core, light blue outer flame. 2. Trial cutting detection. Cut a 100 mm straight line and detect the following indicators. Incision width, 1.5 to 2 millimeters. Matching the nozzle model. Perpendicularity, less than or equal to 5% of the plate thickness, 20 mm plate, tilt less than or equal to 1 mm. Slag hanging amount, slightly easy to fall off. If out of tolerance, reduce the speed by 10% or increase the oxygen pressure by 0.1 megapascal. Next is the formal cutting. 1. Startup process. 1. System startup. Turn on the smoke exhaust system, air volume greater than or equal to 2000 cubic meters per hour, and start the robot in automatic mode. 2. Process monitoring. Observe the flame stability, maintaining a neutral flame, and slag spraying vertically downward. 4. Thick plates, greater than 50 millimeters. Perform layered cutting. Divided into 2 to 3 passes, cutting depth 20 to 30 millimeters for each pass. 2. Exception handling. 1. Midway flame out. Pause the program and check the gas pressure and carbon deposition on the ignition electrode. 2. Path deviation. Return the manipulator to the origin and check the encoder signal or external interference. Then comes post-processing and quality inspection. 1. Workpiece handling. 1. Slag cleaning. Use a copper spatula to knock off the oxide slag. Avoid damaging the incision. 2. Deformation correction. Flatten the workpiece with a hydraulic press. Operate when the temperature drops below 50 degrees Celsius. 2. Quality inspection. 1. Dimension detection. Detect the 3D profile with a laser tracker, tolerance plus or minus 1 mm per meter. 2. Section inspection. Visual or microscope observation for no cracks and slag hanging less than or equal to 0.5 millimeters. What are the requirements after robot flame cutting? Let's learn together now. The grinding requirements are as shown in the table. Note: if the cutting blunt edge is too large, grind the entire cutting surface to meet the blunt edge requirements. If the blunt edge is too small, grinding is strictly prohibited. Next, let's learn about the safety and maintenance of robot cutting and blinking operations. 1. Safety regulations. 1. Personal protection. Wear fireproof clothing, flame retardant index greater than or equal to 8 PV 50 calories per square centimeter, and a mask with a shading level greater than or equal to 5. 2. Area management. Set up a warning area with a 2-meter radius, and prohibit personnel from entering when the robot is running. 2. Maintenance of equipment. 1. Daily maintenance. Clean the nozzle carbon deposition daily and check the wear of cables/gas pipes. 2. Regular maintenance. Calibrate the manipulator 0 point monthly and replace the reducer lubricating oil, ISO VG320. What are the common issues in robot cutting and blinking operations? Let's learn together now. 1. Rough cutting surface. 1 cause: manipulator jitter or uneven speed. 2. Solution: check the servo motor torque and reduce the acceleration by 50%. 2. Unstable flame. 1 cause: imbalance between gas and oxygen ratio. 2. Solution: adjust the mixing valve until the ratio of propane oxygen equals 1 to 3.5. This lesson is concluded. Thank you for listening.